Let's look at another example of the use of statics in a two-dimensional setting, and let's look at the question of finding support forces for a given two-dimensional object. So suppose I have a beam with a 1 meter span that's subjected to a 100 Newton load 30 centimeters from its left side. And let's find or determine the reactions that the supports have to give to my object so that it will be in equilibrium. So first thing I want to do is make a free body diagram, and in my free body diagram I'm going to show the vertical reaction force that I have from the support on the right, and for the support on the left I have a vertical reaction force and a horizontal reaction force. And there is, of course, the 100 Newton force acting in the negative y direction. So to determine the unknown reactions, notice there are 3 of them, and so it's a 2D problem, so there's 3 equations of equilibrium, non-trivial equations of equilibrium, and so I can use those to find the 3 unknowns. So if I start with the sum of the forces in the x direction, I immediately find out that ax equals 0. If I look at the sum of the forces in the y direction, I find that there's an interrelationship between ay and by in the problem. And if I look at some of the moments about A, and that's a convenient point because 2 forces pass through it, so it eliminates them, I find this relationship that allows me to determine what By is. So I find out that By is equal to 30 newtons. And knowing what By is, I can go back to my equilibrium equation in the vertical direction, and I can figure out what Ay is. And so Ay is then can be determined to be equal to 70 newtons. So had that wrong there. So if I plug in 30 into here, 30 minus 100 is minus 70. I take it to the other side. I get Ay equals 70 newtons. So I get my 2 reaction forces, By and Ay, for my structure. And knowing those, for example, in fact, knowing all the support reactions allows one, for example, to properly design the supports for the structure. So that's just one very simple application of statics to the two-dimensional setting.